Alrighty. Thanks, Pocket Network, for hosting us, and it's great to see middleware kind of having its own day in the sun. Middleware is very important. People often kind of assume it doesn't kind of make a difference, but if we all work together and kind of build in this composable open way, then we make it easier for everybody to kind of level up and leverage our technologies. So yeah, this is it's really great to be here. I'm head of ecosystem at Streamr Network. Streamr Network has been building for 5 years, building this decentralized pub sub, and let's get into it. So what is Streamr? You can think of it as a way to stream data to any number of Ethereum accounts, or we are chain agnostic, but we're in the Ethereum ecosystem at the moment, so any Ethereum accounts in real time. And here is the main promise of the network. It's to move data from all the publishers to all the subscribers through decentralized network topologies. And another way to say decentralized network topologies is a mesh network, if that helps you visualize things. So a quick overview of how data flows over Web 2 today. There's this central middle piece, and this is defining of PubSub. And PubSub is a fantastic network architecture exactly for this decoupling. You don't have to worry about scaling. It works very well. Publishers don't need to connect to the subscribers. However, there is this kind of centralized point. And of course, this ain't no good for Web3. And it's typically some sort of SLA commercial agreement with Google, Amazon, whoever. And this is kind of, we can do better. So the Streamr Network essentially removes this middle piece, and it replaces it with a people's network of nodes that can be run by anyone, and they all share the responsibility of pushing the data around. So just like in traditional Web 2, where the publisher doesn't need to connect or know where all the subscribers are, we achieve this decoupling through peer-to-peer technologies, crypto, all this good stuff that I'll get into shortly. But maybe another takeaway here is that in Web 2, the data kind of flows vertically through these data centers. In Web 3, it's more horizontal. Okay, so more definitions, because this is like, if your head's in blockchains, try think more IPFS or BitTorrent. We are a peer-to-peer network that works on classical networking protocols. WebRTC is how the data flows, and sort of like the main offering is off-chain communications and these peer-to-peer data channels. What is on-chain, though, is our access control, so think quite similar to the LIT protocol, and we use the blockchain's cryptography and identity, and we also have the incentivization layer on the blockchain. So that was all a little bit abstract. Let's get into a bit more of a example. So this is the Streamr.network website, and it's just like any website. You load JavaScript and image assets from a centralized source, but if you scroll a little below the fold, you get to this data feed. And what's interesting about this data feed is that this data is not coming from the centralized server. It's not coming from the same place as the JavaScript and the images. It's actually coming from other visitors that are visiting the Streamr.network website in real time. So this is another visualization of what we're looking at here. So this is the stream ID in the top left. So this data feed is a stream on the Streamr network. And it's essentially created this mesh topology of all the visitors that are visiting the Streamr.network in real time. It's interconnecting them through these WebRTC peer-to-peer connections, and they are sharing the data from the data feed. So this is a peer-to-peer data feed. Okay, so what are the properties that we get when, what are we designing for essentially? The big one is to be fast, in other words real-time, and scalable. So this is certainly not easy to do, and blockchains, they focus on block times of seconds, tens of seconds. We operate in milliseconds, and we have this luxury because we don't have validators, we don't have consensus. We can really be very, very fast. We can offer very fast data pipelines by removing this need for consensus. We are all the good things that the decentralized space is: permissionless, censorship resistance and whatnot, tamper-proof, so every single data point and message is cryptographically signed by the private key of the data publisher. So this data cannot be manipulated. You know exactly who has sent the data, and it's all end-to-end encrypted if you choose. And it's also green, so this is an interesting one. So we don't yet have the hard data on this, but we can imagine that in some use cases, it's going to be far more energy efficient to use the latent bandwidth of already on devices to power this infrastructure against using these always-on, power-hungry data centers from Google, Amazon, whoever. So we're quite excited about this. And it's also free to use with the caveat that there is an incentivization layer, and that incentivization layer is quite important for the more production or business value use cases. So it's kind of freemium built into the protocol, and I'll get to that a little later. So a kind of a test that we ran, is this thing scalable? We ran 3 test nets last year. We kind of upped the ante each time, up to 92-ish thousand nodes that were interconnected at once. And at the time, this was one of the biggest peer-to-peer networks in history, and we were able to push data around and have everybody in that network receive the data points within an average of 350 milliseconds. So basically, this graph here shows a logarithmic relationship between the latency and the number of nodes in the network. And this is basically proving the scalability of the network to hundreds of thousands or many multiples of this. So it keeps the real-time properties while being able to scale. So this is our key innovation. So let's talk about the data propagation here. So as I mentioned, the data flows through these WebRTC data channels. If you're not familiar with WebRTC, it is it's the underlying technology that browsers use to power Zoom and Google Meet. It's a video conferencing protocol, but it has this data channel that could be used for any sort of data. So we leverage this so that we can create peer-to-peer connections among browsers and other devices, and it also has these other great properties of being able to push through NATs and difficult firewalls. So a very difficult problem in the P2P space is exactly this, being able to make these peer-to-peer connections, say from my phone to someone's phone in the audience. It's actually very difficult to do with any technology. So I'll get into how the incentive layer solves this problem in a little moment. But let's also reflect on the fact that this is a protocol of shared responsibility, and the nodes connect to neighbors at random. So an example here, maybe I can, if it's in the right pocket. So let's say there is some really interesting data feeds or any sort of sensor feed coming from my phone, and everybody in the audience or everybody in Bogota wants to ingest this data in real time. There's 3 ways to do this. Everybody connects to my phone gets very hot, and this doesn't quite scale, of course. The second way is for my phone to connect to some beefcake server. Everybody connects to the server, and that works. This is the Web 2 way. The Web 3 way is that everybody runs the Streamr protocol and operates on this idea of shared responsibility, and everybody, this phone would connect to 4 people at random. Those 4 people would connect to 4 other people at random and kind of circulate the data in this way. And this is how the protocol works, this is how it scales, and this is how it's so fast. Okay, so now I'll briefly touch on the access control. This is the part that's in the blockchain. It defines who can read and write to the network. And what we can do with this is some really interesting use cases. So kind of like the lit protocol guy mentioned, his token gating access control. We have something very similar, and we could probably compose with what lit has built as well. But if you could imagine, you need to own a certain NFT to be able to publish or subscribe. There are marketplace smart contracts that can enable these data monetization use cases where you can push ETH or whatever token into a contract, and it would give you this time-based subscription to subscribe to a collection of data streams. So this enables a fair data economy through trustless, permissionless infrastructure. So this is the most technical part of the talk. So apologies if we lose anyone here. But I just wanted to talk briefly about how the peer discovery and peer maintenance works on a peer-to-peer network. Essentially, we have 3 layers. This is not analogous to blockchains. This is just our own how our own tech stack works under the hood. It is a multi-level DHT, which is very novel in all peer-to-peer networks. And the bottom layer is this global DHT. We're working on better analogies here, but imagine this big roundabout, or this is where all the nodes in the Streamr network can kind of talk about the control traffic and figure out where the stream nodes are. Next up, higher up the level, is the stream-specific DHT. And you can think of this as kind of like a city map. This is just the nodes that are in the streams. So maybe a quick point here is that the Streamr network is a constellation of these stream topologies, or a bunch of different mesh networks that are connected by this layer 0 DHT, but are also kind of in their own zone as well in this layer 1 DHT. And then finally to the layer 2, which is the WebRTC noiseless data transport, where data can really flow as fast as possible through this interconnected node network. So I just wanted to, I've been waiting a long time to put in this GIF because it brings me a lot of joy, but what about security? So if that all sounded too good to be true, and why doesn't it exist already? If there's some sort of skepticism going off in your mind, that's very rational. So under ideal conditions, peers are honest and they stay online, i.e. they don't churn, and peers they transport the messages as they should. They should follow the protocol rules, but we all know that the real world is very different to what we want it to be. Peers come and go inside the streams. They create churn. There is a problem of free riders that all decentralized systems have to figure out how to solve, and there can be downright jerk nodes that just try and want to mess things up. So we need to make sure that we protect ourselves from this, because the network, anybody can run the nodes. So how do we solve this problem? So there's 2 main attack vectors that we need to consider: Eclipse attacks and DDoS attacks. So the Eclipse attacks is kind of, as you imagine it, it's where a good guy is kind of blocked out from the rest of the network by kind of these malicious nodes swamping the good guy and blocking the good guy's view of the network. So this is clearly not good. And DDoS, maybe we have a understanding of this already in Web 2, and it's very similar in Web 3. In these peer-to-peer networks, your IP is exposed, and let's say it's you have a state-level actor, and they really want to attack a publisher node, a data provider. We need to make sure that they can't target any particular node in the system. So the security measures that we put in place, randomness, it's kind of familiar to all decentralized systems. Random connections are difficult to predict and difficult to kind of know where to attack. and redundancy. And redundancy is this catch-all phrase, I think, that basically means decentralization and defense from these sorts of attacks by just being having more good guys than bad guys, which starts to kind of lead into the incentivization layer of the network. So the incentivization layer is a key part of the security of the Streamr network. How it works is that there are these bounty contracts that a stream sponsor creates. So this is typically the stream creator, but it can be any sort of stakeholder that's interested in funding the security of a particular stream. And what it does is that it incentivizes broker nodes to come join the stream topology and provide this backbone for the stream topology. And what this does is it creates, well, it gives three new properties to the topology: connectivity, security, and privacy. The connectivity, so like I mentioned, my phone is going to have a really hard time making a peer-to-peer connection with one of the phones in the audience, just because peer-to-peer connections are so difficult over the internet. But if we incentivize these broker nodes to come in from the open internet, data from my phone can connect to one of the nodes in the open internet, and the same with the phone in the audience. We can kind of have this peer-to-peer relationship through this third party, and then, as you can imagine, it expands to many other nodes as well. Security. So again, power in numbers. It's very difficult to DDoS a network of 1,000 nodes with a lot of, and that kind of brings message redundancy, which reduces the chance of any sort of packet loss. And privacy. So in a small networking topology, it is much easier to understand who is publishing data into the topology and discover the IP address and attack that particular machine. Again, in these larger topologies, this is much more difficult. So you get privacy, connectivity, and security by incentivizing a lot of good guys to come in and be this backbone to these stream topologies. And these bounty contracts have staking and slashing mechanisms as well. So that means that these broker nodes, they come in, they need to stake tokens, and they expose themselves to slashing if they are free riders or malicious nodes. Okay, so now we kind of have an idea of how the network works and what it is. What are the use cases? So I think there's two main buckets that we can think of here. This is generalized messaging and open data sharing and data monetization. So on the first bucket, I guess, is generalized messaging. So imagine the Streamr network could be this decentralized WhatsApp of Ethereum. So this is a chat room, and a chat room is synonymous to a stream on Streamr. And these participants have publish and subscribe. They have read and write access to the stream. They push messages, and these messages appear as messages. And so we have this chat app. Every man and their dog has a chat app these days, but this doesn't have any servers. This is peer-to-peer connections. This is tamper-proof, secure, decentralized communication. I think this is a big deal. There is decentralized live metrics gathering. So all decentralized systems have this problem of how do you gather metrics from the nodes themselves inside the network without reaching for centralized technology. Today, a lot of even the top 10 projects, they reach for kind of some sort of Datadog or some centralized way to get a real-time view of the network. But with Streamr, you could actually, if you pair the Streamr node with the node of the decentralized network, you can create decentralized data gathering and real-time insights for the whole thing. And kind of on the same vein as this, this is interconnecting that decentralized system as well. So a project that we are working with, I can't announce it yet, but it's sort of very exciting is they are sharing their local real-time state, observed block time, memory usage, CPU usage, etc. From the nodes themselves. And so this extends a decentralized system without compromising on the decentralized nature of the system. So it's kind of like the perfect fit for the technology. And then if you caught Redstone's talk earlier today, they were talking about oracles. So the Streamr Network powers that first mile of data transport between the data providers and the Redstone cache nodes. And we kind of sign and broadcast that first mile in a decentralized way. And this is a little experimental, but this is kind of like an internal idea that we're bouncing around, that I'm sharing it because it's interesting to this crowd especially, is that we can kind of scale the RPC layer in some certain use cases. So imagine you have a very popular DApp and 10,000 browsers are all polling the RPC. RPC is getting overloaded, and it's all just interested in one kind of event stream. What you could do is you could have a handful of nodes, or however much decentralization you want, that connects to the RPC layer and does that polling. So instead of 10,000 nodes or 10,000 devices hitting the RPC, you have a handful. But those handful of nodes then are running the Streamr protocol, and all your dApps are running the Streamr protocol. And it sort of load balances those events that would have all had to come from the RPC. It load balances where the dApps are actually getting the data from other dApps, all in real time. So this is a really interesting way to kind of scale Ethereum, scale RPCs in a decentralized manner. Okay, moving on to open data sharing and data monetization. So this is a bit more on the Web 2 side, and we don't look exclusively in Web 3 use cases. We are just as useful in the Web 2 space, and we have a real opportunity to kind of execute on the vision of the open data mission, which is to make data as accessible as possible. And if you're familiar with government data hubs, it's usually some spreadsheet or something where they say they promote open data. But if they were using Streamr, they could really level up and promote real-time open data from smart cities and whatnot. So one example, well, not one example of a smart city, but one example of data monetization that uses Streamr as its data pipeline is Swash. So this is a browser extension plugin that monetizes your browsing data with your full consent. You get to own your data, and the data flows through these open permissionless data pipelines provided by Streamr. And yeah, it's like an interconnected browser network of tens of thousands. And similar pattern, we have a project in our ecosystem called Demo, which is doing exactly this for driving your car around. So this is a Raspberry Pi style device that plugs into your car, ingests the data, pushes it through Streamr, and then composes with the access control so that when folks come in and buy access to those collections of data streams that you're pushing, that thousands of people or even millions of people are pushing into those same data streams, the same shape of data, manufacturers, governments, whoever, buy access, send tokens into those contracts, and then those tokens get evenly distributed amongst all the data providers that help to create this data set. So this is the data union concept that we're very proud to support over the Streamr Network. Okay, that's all. If you have any questions, please reach out to me. This is the Telegram, whatchamacallit. And yeah, thank you very much.